Hey everybody, today we're going to be learning a little bit more about surface area and diving in just a little bit more to the idea of surface area. And surface area is the amount of space on the surface, the area of the surface of a 3D object. And so today I raided my pantry to find a few 3D objects to help us. I have a granola bar box to help us with prisms, and I have a soup can to help us with cylinders. So we're going to talk about both of these in just a second. The first thing that I want to do is I want to look at this this granola bar box. When we're talking about surface area, companies who make these boxes have to figure out how much area of cardboard do they need and what's the best area to maximize their cost when they're producing these things. It still fits the right amount of granola bars that they need. So it's still got to have the right volume as well. And so we're going to be talking about surface area today. And when we break this surface area or this shape apart, one of the things that I want you to notice is we have a two-dimensional object that lays flat, and we call this a net. And this, you should have watched this and known this from your videos today, but I just want you to see this is the net of my box today. And so if I have a rectangular prism, and I'm going to guess that on this box it's about I don't know, I would say like 4 inches by 6 inches, and maybe 4 inches by 8 inches by 2 inches. We're just going to use those numbers for today. So I've got my rectangular prism of my granola bar box. If I were to draw a net of this box, sometimes it's helpful to see the bottom there. So we can draw those dotted lines in. I typically start by drawing the bottom of the box. So in this case, the bottom of this box is 4 inches by 2 inches. And then I kind of unfold it in my mind from there. So I take this box, and here's my bottom. This part is the 4 by 2. And I typically then try to like fold out the sides. And I didn't cut this the right way to do this, but then I fold to my left, I fold here, and we know that this side, and I didn't leave enough room on my whiteboard, is going to be pretty long. So let me try this again. There's my eraser. I'm going to have to draw this net a little bit smaller. This is 2 by 4. If I drop this left side, it's a pretty long side, and so I'm going to drop it. When we've been doing compound shapes as our warm-ups, we know that parallel sides are always going to be equal. So 2 and 2 have to stay here. This long side is going to have a length of 8. And then the left-hand side is going to drop down the same way, and it's going to be the same. It's going to be 2 by 8. And then we can pull the front down. Here's that front of the box. That front of the box is 4 by 8. And so here is 8. And then the back of the box is going to be the exact same way. It's going to be 4 by 8. And then a lot of people want to stop here at their net. Remember that this is kind of like a piece of dice. A piece of dice is a prism. And think about how many sides a piece of dice has. This shape is going to have 4 rectangles. 1, 2, 3, 4, 5, 6. I mean 6 rectangles. I think I said 4. It's going to have 6 faces, and so we need to make sure that when we draw the net, we also have not just 5, but we have 6 faces that we draw. And so here's that top part of the box that sometimes people forget. And then here's where sometimes it gets a little tricky to label. Think about the top of your box. The top of your box is going to be 2 by 4. We know that sides are parallel. These are 4, so this has to be 2 and 2, and then this is 4. When I go to label more, when I think about this side, I can think about here's 8 and here's 8. One of the most common mistakes I see is that people want to label these 2 corners different things. These 2 corners different things. Whenever you have 2 sides that come together as corners, and obviously my net is not drawn to scale here. Whenever you have 2 sides, when we fold this shape back up, these 2 sides are going to come together. So I'm going to show you that on this box here. Here's a corner. These 2 sides have to be the same and match up because when they come together on my box, they're going to be the exact same. Same thing on this corner here. When you have a corner cut out, this side and this side have to match up because when we fold it together, they have to close up that space. They have to close up that box. Same thing down here. Same thing on this corner. These two are going to be the same. And then we're going to keep folding. So when we're drawing nets, that's how we draw nets. And then we find the area of each rectangle. We've taken this like complex shape. We take the area of each rectangle. Here's 16. Here's 32. Here's 8. Here's 32. Here's 8, and here's 16. And then how do we find the area of all of them together? Well, we add them up. And so you can use your calculator to do that. You can add up with me. You can do 32 plus 32 plus 16 plus 16 plus 8 plus 8. And when you do, you should get 112. 112 inches squared would be my label on there. Now, you don't have to always draw a net. There is going to be a question on your test that asks you to draw a net. Today on the exit slip, since it's digital, I'm not going to ask you to draw a net. But I am going to ask you to find the surface area. And so the other way that I sometimes find surface area of prisms is I just think about my top and my bottom. What's the surface area of my top and bottom? Well, this is 4 times 2, which is 8, but then there are 2 faces, so I multiply by 2, and I get 16. I'm going to free up some space here by getting rid of my net now. Then I think about my left and my right, my left side and my right side. And my left side and my right side are 8 by 2. So 8 times 2 is 16 times 2, because there's a left and a right, that's 32. And then I think about my front and my back. So notice I've got all 6 sides listed out here. My front and my back are 4 by 8. 4 by 8 is equal to 32. But then there's a front and a back, that's 2 sides, which is equal to 64. And then I add up all those things together to give me my total, which is again 112 inches squared. I get the same answer whether I draw a net or I do it this way. It's just 2 different ways to think, and it's totally up to you on what you decide to do here. So then the last thing that we're going to do is find the surface area of a cylinder. And again, I told you I have a cylinder with me here. It's a can of soup. And so we notice that the surface area here has a circle on top, a circle on bottom, and then it's got this part around. And sometimes it's hard to visualize what that shape is, so I have taken the soup label off for you to show you that soup labels are actually just a rectangle. They're just a rectangle wrapped around the cylinder. So if I unfolded this cylinder all the way, and I'm not going to take the top off this soup can, there would be a circle here, there would be a circle on the bottom, and then a long rectangle that goes around the can. And so the net of a cylinder, I'm just going to show you, here's my cylinder. A net of the cylinder often looks something like this. Here's the net, here's the cylinder. Okay, and so for my soup can today, I'm just going to say that it's 4 inches tall, and I'm going to say that it has a radius of 1.5 inches. What you'll notice is that when we draw out our net for surface area, we have 2 circles, and if you remember the area formula for a circle, it's pi r squared. Pi r squared, pi r squared. So I have 2 pi r squareds. So the surface area formula starts with 2 pi r squared because there are 2 circles. And then I'm going to add the rectangle's area. The rectangle's area, if we think about what this length is, I'm going to come back to my soup can. Think about what we call this. What do we call the perimeter of a circle? The outer edge. When I unfold this soup label, it is the length that goes around the circle. So the length of this rectangle is the circumference of my circle. And the circumference formula that we know is either pi d or 2 pi r. I'm going to use 2 pi r today. And then the other dimension of this rectangle is not just the cylinder or the circumference, but it's also the height. And so we multiply by h. And so that is the formula for a cylinder. 2 pi r squared plus 2 pi RH. And I will give that to you on a test quiz or exit slip, but I just wanted you to understand where it's coming from. And so from here, I can plug in my values over here. I can plug in 2 times pi times my radius is 1.5 inches squared, plus 2 times pi times my radius is 1.5 inches squared, and we said the soup can for today's purpose, we called it 4 inches. And so I plug all those numbers into my formula, 2 pi, and then r squared was 1.5 squared, plus 2 pi times radius is 1.5, times my height is 4. And then I'm just going to pull out my calculator, and I'm going to start to plug and chug. I have 2 times 1.5 squared, and remember that you do need to use order of operations, so 1.5 squared times 2, that's 4.5 pi for the first part of my formula. Then 2 times 1.5 times 4 is 12 pi. So I've got 4.5 pi and 12 pi. I'm going to add those two things together and I get 16.5 pi. If they wanted the exact surface area of this cylinder, we'd be done. 16.5 pi inches squared. If they wanted an estimated surface area, I would actually have to plug that into my calculator. So here's the exact. If they wanted an estimated, I would have to do 16.5 times pi using the pi button, or 16.5 times 3.14. I would accept either. 16.5 pi. And when I do that, I get 51.8362, and it keeps going. And typically, we're going to round that to the nearest 10th or 100th. Today, we'll round to the nearest 10th. So on this one, my 8 looks at my 3. My 3 tells me to round or stay the same. And so I get 51 and 8/10 inches squared. This is my estimated surface area. This right here is my exact. And I found both of those by using the formula for surface area of a cylinder, 2 pi r squared plus 2 pi RH. And hopefully you understood where that formula came from with my soup can here. So today you're going to be continuing to work on surface area. Hopefully this mini lesson helped, or you can go back and look. Also, as you're going today, there is at one point I'm going to ask you for the code word. The code word today is soup. So if you watched and listened all the way to the end of today's lesson, it's a 4-letter word. The code word for today is soup, S-O-U-P. See you later, guys.